Hello and welcome back to SkillBuilders webinar, which is looking at new features of ZFS in Solaris 11. Okay. In the earlier presentation, we looked at ZFS changes in terms of NFS and how you can share NFS file systems. There's a couple of facilities left to look at in the second part of the presentation, which are looking at three major facilities. First of all, a new deduplication facility to save on space. Secondly, the ability to perform what's called shadow migration, where you can move the contents of a file system to a ZFS dataset while using the new dataset as though it was a complete copy. And then lastly, splitting a zpool, being able to take away a mirror component but actually export it and mount it as a fully operational new pool, which can be quite handy in a number of circumstances. Okay. First of all, we're going to look at data deduplication. On the right hand side here we have a Solaris 11 system based on a logical domain with the necessary disk resources allocated. Okay. We are using virtual disks, so the performance probably won't be quite as quick as if you have physical disks or SAN LANs, that sort of thing. Excuse me. Now let's have a look at deduplication. This is a new facility in Solaris 11 and it potentially can save an awful lot of disk space, and the performance of it does seem pretty good, although that's obviously up to you to judge if you use it in a real practical situation. So let me show you how you use it. There's a lot of theory of deduplication and lots of recommendations of different ways to go about it, but in ZFS they use it at block level. If you look at the paragraph that I'm circling now, you can read the statement by one of the ZFS developers concerning the reasons why they chose to use the block level mechanism. Okay. On the surface of it, you might think that it causes some processing overhead, but the results that you get when you try it are a little bit inconsistent and that's not always true. Okay. Here is an example on this page of creating two different Z pools. The first one does not have deduplication on, and the second one does. And there's a simple little test using the time utility to compare how long it takes to copy the same files to each type of pool. So let's have a look at how you do this. First of all, we'll create a pool. There's no need for the -f unless there was a previous file system on the device we're going to use, called Lake No Dedup. And the device I'm going to use is C2 D3 S0. Then I'm going to create a file system under that, a dataset. Called Lake No Dedup /data1, which will of course be mounted on /Lake No Dedup /data1. And I've pre-prepared a few files. In the notes it says they're about 1.8 gigs. Well, just to speed things up a bit, I've made them slightly smaller. Okay, so they're progressively bigger. The smallest one, 72 meg, the next one double that, and the next one 3 times. Okay, and they do have similarities within them, but you can see they are different files, so let's have a go at copying them. We're going to copy A* to /Lake No Dedup data1, and let's see how long that takes. It shouldn't take too long. I would estimate around 12 or 13 seconds. It's got me wrong straight away. 19.8 seconds. What we'll do now, we'll create another pool. Called late dedupe this time, and which is going to be on C2D3S1. So it's the same disk, just a different partition. Hopefully that will balance up the performance a little bit and make it more realistic comparison. And then we're going to create a data set within this with deduplication on. So we're going to show. I'll also show you this first example here, which is actually setting dedupe on in the newly created lake dedupe. I could have done this actually from the zpool create command line, and then I'm going to create another file system. Now actually I don't have to put -o dedupe because the dedupe property is inherited. So if I left that off, the dedupe property would be inherited all the way down through the datasets in the pool. But I'll do it anyway just to show you how it can be done. In a pool that doesn't have deduplication, you can still have deduplication set on for individual datasets. So it's entirely flexible. Oops, I missed a little bit of syntax out there. And I missed out the correct name. That's more like it. So if I do ZFS get -r dedupe in lake dedupe, you can see the dedupe property is on. And I did specifically set that on with the create and with the set. Now let's do the copy. This time to lake dedupe. And let's see how long that takes. It may not take so long. Well, there we go. It's actually quicker. I'm not sure how far we can trust the figures because of the basis of the way this thing demonstrates. But the other important thing, of course, is how much space is it taken up, because apparently we should have the same amount of space occupied for each pool. But if we do a zpool list, late dedupe is occupying 145 megs and late no dedupe 433. Now that is quite a difference, and there you can see straight away the benefits you get from deduplication. Quite stunning, really. I'm sure you wouldn't get that in every situation, but you're definitely going to get some benefit from this facility, and it is so simple to use. All you have to do is set the dedupe property on. There's no further administration required. Okay. If you're copying large amounts of data, ZFS has a bit of a lag in terms of, for example, when you remove space, you don't necessarily see the free space straight away, and the same thing when you're writing. So if you see slightly odd values, wait a little while and then run the commands again, and the thing will correct itself. Now, if I copy files within the deduplicated dataset, okay, if I copy, let's copy that big file. And why not create another copy? And for good measure, let's see what DU thinks we're using. Getting on for a gigabyte. Let's see what zpool list thinks we're using. Quite a lot less. So almost down to about 22-23% of what the system storage is actually used, which isn't bad. You do get some strange side effects if you start filling up the thing rapidly. You could, in fact, theoretically, sort of overtake what the physical capacity of the file system is, and the system adjusts things. If we do a df-h pipe into grep link, you can see already that although I created the partitions that I've used, by the way, are exactly the same, and you can see that late dedupe now actually appears to be bigger, and if I carry on copying, that size will actually increase, and that's how the system deals with trying to keep the illusion of the space used with no dedupe. So an excellent facility and so simple to use. Okay, now another option that's available, although Oracle don't recommend you use this. Oh, excuse me. Instead of setting dedupe to on, you can set it to verify, and then further verification is carried out rather than relying on the underlying checksumming, and that takes a little bit longer and it will reduce performance. Okay. And there, just one further illustration of the size changes as you copy more data compared to what you saw previously. Okay, so that's deduplication. Another handy facility is something called shadow migration, where you can take an existing local or remote file system, UFS, ZFS or whatever, NFS mounted if you like, and you can migrate it to a ZFS dataset and be using that new ZFS dataset as though it was a complete file system while the migration is going on. Okay. You can only do it copy from a read-only file system, so if you look at the bottom here you can see that you have to have the read-only property on a ZFS dataset. If it's a UFS local one, then remount it with the read-only option. If it's NFS, make sure it's shared read-only from the server. Secondly, you have to have an additional package installed, which might not have been there when you installed Solaris 11 in the first place, and you have to do a pkg install shadow migration. You can learn more about the packaging system and installing Solaris on the full 5-day transition to Solaris 11 course that's available from SkillBuilders. Okay, once that's installed, imagine that we have a remote machine that has a directory on it called /software. As it happens, I happen to have one here. The name of the machine is actually Whale, so the command I'm going to use is slightly different. Okay, and I'm going to put it into my rpool because I have more space available in that particular zpool. So I'm going to do ZFS create ZFS create -o shadow equals NFS / whale, which is my server, /software space rpool /software. prompt came straight back. The migration is going on in the background. I should be able to ls/r pool/software, and the actual source of /software has got quite a bit of stuff contained within it. Various course templates and Solaris distributions and so forth, but I can access it as though it's already complete. Okay. So you can use that dataset and that directory quite happily as though the whole thing is there. And in fact you can use shadow stat to watch the progress of the migration. Okay, it's complaining that I don't have the shadow D daemon enabled, so shadow D, and let's try shadow stat this time. Okay. Hopefully this will start outputting some data to me fairly soon. There we go. The transfer is treated as a bit of a background process, and the program does seem a little bit erratic. You can see sometimes you're reported on the amount of space left and sometimes it doesn't. And here, as an example, if I do a Control-C out of this, you can do df -h, and let's have a look for whale, and there you can see the mount. And when the migration is completed, the file system will be unmounted. Okay, so we can leave that running. Hopefully it won't fill up my RPool before the end of the presentation. Okay. The last thing I want to show you is how you can actually split a zpool. Now this can be done on any sort of mirrored pool. Obviously you need a mirror so you can split a mirrored component, but what you could do on a small scale server, you could for example add an external disk drive and zpool attach it to your root pool, wait until the disk is resilvered, and then split the pool, and you've effectively got a backup. And you can actually mount that pool, you can import it on another mount point on the same machine, or indeed, because it's an external removable drive, you can take it somewhere else and mount it there. So quite useful. If you just do a zpool split, the last device that you added is the one that is split away, but you can give the command line another option which allows you to define the actual physical component you want to split. Here's an example of a zpool that has got a 2 mirror component. Let's make one. Okay. Let's use Lake no dedupe because there's not an awful lot of space actually occupied. Oh, why don't we use Lake dedupe instead? Okay. So there I'm attaching a new component to the existing component C2 D3 S1, and that will now, where it wasn't a mirror before, it will now be a mirror through the wonders of the zpool command, which hopefully we can see. There we go. The system's a bit tied up doing lots of disk work. Let's just have a look at Lake dedupe, shall we? That's better. And it's already resilvered. Wasn't that amazing? So let's split it. There, we split it. We still have our Lake dedupe mounted. And there it's not a mirror anymore, we've removed one of the components. Okay. If we do a zpool import, we can see that the zpool split has created a new pool which hasn't been imported by default. So we can do zpool import Lake dedupe new. And there it is, on a completely different mount point, and we can use it as a separate pool. So that used the most recent disk I added to create the split pool. I can actually specify it. If you look on the left hand side, you can see I can actually specify the device name to split away. And you can also split and automatically mount by using the -R and the directory name to automatically import and mount the split away pool. Now there are other features with ZFS in Solaris 11, including a new iSCSI server and client mechanism, and also you can now encrypt data sets as well. So a lot of new features, and well worth the switch to Solaris 11. Okay, and I hope you enjoyed the presentation, and I hope the features were of interest to you. Thanks for attending, and we hope to see you on the full transition to Solaris 11 course. Please feel free to contact SkillBuilders, www.skillbuilders.com. Okay. SkillBuilders have skills in lots of different Oracle areas, including Oracle database, database administration, database development, database performance tuning, database stabilization projects, and in addition skills with the Oracle servers, especially the new T-Series T4s. Thank you very much indeed.